There are two standard systems for determining a prescription for eyeglasses. One is to have the patient look through a large device called a phoropter, fitted with dozens of different lenses that can be swung into place in front of each eye in various combinations, while a patient tries to read a standard eye chart on the wall ahead. The other uses a more expensive system called an aberrometer that shines a laser into the eye and uses an array of tiny lenses to measure its characteristics. Now, a team at MIT's Media Lab has come up with a much quicker, simpler, and cheaper way to get the same information, a method that is especially suitable for remote, developing world locations that lack these expensive systems.
Our device has the potential to make routine eye exams simpler and cheaper, and therefore more accessible to millions of people in developing countries.
In its simplest form, the test can be carried out using a small plastic device clipped onto the front of a cell phone screen. The patient looks into a small lens and presses the phone's arrow keys until a set of parallel green and red lines just overlap. This is repeated 8 times, with the lines at different angles for each eye. The whole process takes less than 2 minutes, at which point software loaded onto the phone provides the prescription data.
People have tried all kinds of things, some really clever. What's really great about our technique is that it involves no moving parts, and all the intelligence is in the software, so we can make it really cheap and easily accessible.
The device uses an optical system derived from a similar system some team members developed last year as a way of producing tiny barcodes, called barcodes, that could provide a large amount of information.
So I was showing it to my wife, and she looked at it through her right eye, and she said, I can't really see it very well. Very strange. So I asked her to look at it through her left eye. And when she looked through her left eye, she could see it very clearly. And then she reminded me that she actually has differential vision. She has a power in one eye, but not in the other. So, there is something interesting. Barcodes can be actually used to figure out if there is something refractively wrong about your eyes.
The prototype system Raskar and his students developed as a result of that insight has an array of tiny lenses and a grid of pinholes that, combined with the software on the phone, forces the user to focus at different depths, so the eye's focusing ability can be measured. Rather than estimating which of two views looks sharper, as in conventional eye tests, the user adjusts the display to make the separate lines or dots come together and overlap, which corresponds to bringing the view into sharp focus.
Our device is like a thermometer for the eye. Now people can measure the performance of their eyesight at home.